welcome to Erudite Education. We drive to seek knowledge. Today, we are going to start off with the part 2 from our arithmetic chapter, fractions, decimals and percentages, wherein we are going to discuss upon the theory completely based on the decimals part, and in the next lecture, we would be going on to the percentages part as well. So today, in this ultimate guide for GRE Quantitative Reasoning, we are going to cover the part decimals from the topic fractions, decimals and percentages in the arithmetic section. So since the topic itself is decimals, let's start with asking a small question. What exactly is a decimal system? So a system where you can express every number in the powers of 10 is something you call as decimal system. So may that be any number you can express in the powers of 10 in the decimal system. Similarly, just like you can express a number, if every fraction can be expressed as a decimal as well. That fraction may either be repeating or non-repeating decimal, but yes, every fraction you can express it in the form of decimal points, in the form of decimal numbers, in the decimal system, but that decimal may be repeating or non-repeating depending upon the fraction. We'll see at the end of this video what do you mean by repeating and non-repeating decimals. Also, repeating decimals is something that you call as irrational number. So if you see a repeating decimal, obviously that decimal is an irrational number. We'll see what is repeating and terminating decimals. Don't worry, just give a few moments. So for example, we have some number 8631.41 and we need to express this number in the form of decimals. So as I said, decimal system is nothing but to express every number in the powers of 10. So over here I have 1 in my units place, 3 in the tens place, 6 in the hundreds place and 8 in the thousands place. These 4 places we are familiar with. If there was anything to the left of 8, it would be the 10,000s place, lakhs, 10 lakhs and so on. Now this units place is also called as ones place. So in the question they can either give you units place or ones place. To the right of the decimal point is something that we are not aware of, and they frequently ask question from decimals wherein they will specify some numbers which are present at the right of the decimal point and play with those. So over here, the first place to the right of the decimal point is a tenths place. Then you have the hundredths place. You can see there is a change in the spelling. This is not tens, it is tenths. Then you have hundreds, that means 1 upon hundredth part, which is hundredths. Then you have thousands part, which is 1 by 1000, so 9 belongs to my thousandths place. So it is nothing but over here as the name suggests, tenths place, which is 1 by 10. So 1 by 10 can also be expressed as 10 raised to minus 1. So the number, or you can say the 10 power associated with this 4 in the tens place is 10 raised to minus 1. Similarly, the 10 power associated with 1 is 10 raised to minus 2, and the 10's power associated with 9 is 10 raised to minus 3, which is 1 by 1000 or thousandths place. Similarly, when you move to the left of the decimal point from right to left, that is from this right to this left, to the left of the decimal point, the first number you have is the power of 10 raised to 0. So you start from 0 and you go increasing by 1, so 10 raised to 0, then you have this belonging to 10 raised to 1, 10 raised to 2 and 10 raised to 3. So whenever you move to the left of the decimal point, always you have to increment by a power of 1. So 10 raised to a, where a will increase by 1 every time. And to the right of the decimal point, you will always start from 10 raised to minus 1, not 10 raised to 0, 10 raised to minus 1, 10 raised to minus 2, minus 3 and so on. Now when I want to express this number in the powers of 10, so what I'll do, I'll multiply this particular digit by my 10 power and add it to the other numbers. Wherein the other numbers will be similar, I'll take the digit and multiply it with the power of 10, take the digit and multiply it with the power of 10 and so on. So my number can be expressed as 8 into 10 raised to 3 plus 6 into 10 raised to 2 plus 3 into 10 raised to 1 plus 1 into 10 raised to 0 plus 4 into 10 raised to minus 1. 10 raised to minus 1 is nothing but 1 by 10 plus 1 into 10 raised to minus 2 plus 9 into 10 raised to minus 3. So that is how we are going to express this particular 6-digit number over here in the powers of 10, and I hope you guys have understood. The main important point over here was remembering about the tenths place, hundredths place and thousands place, and you should know how to express every number in the power of 10. Now the next topic is how do we express fractions in terms of decimals. That means if I have a fraction, suppose 5 and 4 upon 200, how are you going to express it in the decimal system? So one thing you can do, either convert the denominator to 100 by maybe cancelling out some common factor in the numerator and denominator. So if you take the denominator 100, 257 by 100 would be nothing but you would have 2 decimal points from the right hand side. So that becomes 2.57. So what I've done over here, 514 upon 200 had a common factor 2. I cancelled it both from the numerator and the denominator. So I got 100 in the denominator, which is now giving me nothing but 2.57, which is my decimal conversion of the fraction 514 by 200. Suppose I have a decimal number, I have to convert it into fraction. How will I do that? So the number of zeros of the denominator of the decimal number will be equal to the number of places after the decimal point. For example, I have taken a number 90.17 over here. When you talk about this number, 90 is a whole value and 17 is my fraction. So in my fraction part, I'll have 17 by 100 and 90 will remain as it is. This is nothing but a mixed fraction where you have a whole number along with a fraction. So 90 becomes my whole number and my fraction becomes 17 by 100. Why 100? Because there are 2 places after the decimal point. So 90 plus 17 by 100, you can cross multiply and stuff and you will get a 90 into 100 by 17 upon 100, which is 9017 by 100, which is nothing but 90.17. So in the first slide, we saw about terminating and non-terminating or repeating decimals. So what is a terminating decimal? Something that has finite number of places after the decimal point. For example, try 1 by 8. You can insert the 1 by 8 into your calculator and you can see the result comes out to be definite places after the decimal point, which is 0.125. But try inserting 1 by 3 in the calculator, you will find that you will get answer 0.333333, wherein the 3 go on repeating continuously. They have no end. That means my decimal places in 1 by 3 when expressed into decimal system is the number of decimal places are infinite, they are uncountable, or you can say they keep on repeating again and again. So such numbers where my decimal places do not terminate or they keep on repeating are my repeating decimals, and those where I have a finite number of decimal points after the decimal point, I have a finite number of places, I call those numbers as terminating numbers. So that was it for the theory of decimals. Don't worry, we would be taking up practice questions and we'll be solving them as well. But this was just to give you an insight about what all theory you need to know or you need to remember for attempting the topic of decimals in the GRE Quantitative section. The next video that will be coming up would be based on the percentages, which is again a very important part. So I hope you guys have subscribed already to the channel. If you haven't, then make sure you go and subscribe so that you do not miss out on a single video that I would be uploading. And if you haven't yet followed me, if you haven't yet liked any of my videos, if you haven't watched those videos, first of all go and watch them. Make sure you like those videos, and if you have any doubts or if you want me to make some improvements, you can leave them in the comment section below. Anything from your side is appreciated. And yes, don't forget to like, share and subscribe. Do share the video with your friends if you really like the video. Thank you so much for watching.